Okay, so today we're looking at something called permutations and combinations. We will be using our calculator a little bit, so if you need to get that out, you might go ahead and get that out. So first of all, I want to talk about something called factorial. It's also called the multiplication counting principle. I'll refer to it as factorial because it's easier to say. So I'm just going to pick a number. I'm going to pick 5 factorial. Now, I don't know why they chose this exclamation point as a mathematical symbol for factorial, but that's your mathematical symbol. Now, here's what it means. 5 factorial is 5 times 4 times 3 times 2 times 1. Whatever that turns out to be, that's 5 factorial. Now, let me show you how to, I'm just going to clear this out, how to do the factorial in your calculator. So if I'm putting 5 factorial in my calculator, I'll do 5. And then to get my factorial, go to the math menu and over to probability. I think it's easier to hit the back arrow and it'll take you back around. You'll see number 4 is your factorial symbol. So 5 times 4 times 3 times 2 times 1 is 120. Okay, now we haven't used that yet, but that is factorial. So let's look at situations when it would be used. So we're going to look at 2 of these and then add permutations and combinations. So here's the first one, and it says, in how many different orders can 10 dogs be lined up to be groomed? So if we're talking about the first spot for the first dog to be groomed, if I'm grooming them, which I probably would not be, but if I was, I could pick any of the 10 dogs to start with, right? So 10, I have 10 choices for that first dog to be groomed. Now, for the second dog, I've already picked 1 dog. I've got 9 choices left. Now, do y'all see where this is happening? On the third one, I've picked 2 dogs already. I've got 8 choices left. See how this is becoming my factorial thing? So 10, I should probably put dot 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 because that's continuing on. 10 factorial should tell me how many different ways I could line those dogs up. So 10 factorial. Alright, so my comma would go there and there. So 3,628,800. So a lot of different orders you could pick there. Okay, different question, but same kind of thing. How many ways could you arrange 6 trophies on a shelf? And maybe I should say from left to right. So whichever trophy is first, 6, then I pick that trophy, so I've got 5 more choices, which is 6 factorial. Now I'll go ahead and tell you that's 720. You can put in your calculator and verify it if you don't believe me. Okay, now we're going to talk about, like I said, permutations and then combinations. You probably will want to write down this formula right here. But let me explain to you what permutations are. Permutations are when you're arranging items in a particular order. Now, when we just used our factorial, in those situations you were kind of putting them in a particular order. How permutations are going to be different is that you won't typically use all of the items the way we were grooming all 10 dogs in that first example. How you might change it is something like how many different order could you if you were only grooming 3 dogs. So that means 7 dogs aren't going to be chosen to be groomed, but you still want to have a first dog, a second dog, and a third dog. So permutations, the order matters. That's the key. Now, I gave you a little formula here. In this formula, this is just your notation. N is the number of items you have in your set total. P stands for permutation. R is the number of spots that you're filling. And then here's your formula for it. So this is just notation. This is the actual formula. Okay, so let's look at a couple of questions. So here is our situation. 7 yachts enter a race. First, second, and third place will be given to the 3 fastest yachts. How many arrangements of first, second, and third place are possible with 7 yachts? So order matters, because if you're the second boat that crosses the finish line, you don't get first place. Order matters. So here is my setup, 7 yachts total. I'm going to choose 3 places, first, second, and third. Okay, now that means in my formula, this is my R, and I'm sorry, this is my N, and this is my R. So I'm going to plug into the formula. So N factorial over N minus R factorial. Okay, now I want us to sort of do this one by hand. I want you to see what's going to happen. I'm not going to write this out every time, but I want you to see this, okay? Okay, now I'm going to write out 7 factorial. 7 times 6 times 4, there I go. And I'm going to write out 4 factorial. Now, you can probably guess why I chose to write these out. What you'll notice is that you'll get some canceling to happen here. So really, your answer is just 7 times 6 times 5. And that turns out to be 210. Okay? Let's do one more of these, and then we're going to talk about combinations. Okay, same kind of situation with the yachts, still getting first, second, and third, but this time there are 10 yachts instead of 7. So I would set it up as 10 permutation 3. Now I want to show you how to do this in your calculator. Now you may have some calculators, some no calculators, so make sure you can do it by hand too. Now, if I'm doing 10 permutation 3, I'm going to put my 10 in first. Then I'm going to go get my permutation. I'm going to go back to that same menu that I had a minute ago, over to probability. You might have seen this a minute ago. There it is, number 2. And then I'll put in my R. So see how you need the N at the beginning, then the R at the end. So 720. Now 720, I'll just tell you, is the same as 10 times 9 times 8. So kind of the same as here, where you would go count down until you had done 3 spots. Here it's the same kind of thing. Okay, so let's talk about combinations. Now combinations pretty much like permutation, except with one exception. Order does not matter. So an example of this would be if I were to say, I'm going to pick 3 of y'all out of the 20 people in our class or whatever, I'm going to pick 3 of you guys to go to the office. So it's not like the first person chosen is any different than the third person who's chosen. That order doesn't matter. It's just they're chosen. So that's the difference between the permutations and the combinations. The formula difference is here. So let me give you a second if you need to write that down. Well, if you need to write it down, pause it. But that's your formula. So let me show you how to put this in your calculator. So I'm going to do 12 combination with 3. So pretty much the same thing. Go ahead and put your 12 in. Go to your math menu, over to probability, and there's combination versus permutation. And then put in your 3. I'm going to put an 11 instead of a 12, so I'm going to go back and put in a 12. Okay, so 220. Okay, so let's look at what one of these looks like. So a reading list for a course in world literature has 20 books on it. In how many ways can you choose 4 books to read? So we would have 20 books total, combination with 4. Now see how it doesn't matter which book you read first, you're just going to have to read them. So I'm going to go ahead and tell you, you can put this in your calculator, that it's 4,845. Alright, permutations and combinations, we're going to use them in the next section, so that's the reason they stuck them in here.